Hey everyone, I'm Jamie. In this series, we're building a simple yet complete 2D game engine from scratch, piece by piece, learning as we go. Last time, we set up our workspace from scratch and talked about how to keep the engine, editor, and ECS organized so they don't trip over each other. This episode, we're leveling up that setup by moving to BHVR, Beaver, a more powerful monorepo foundation that'll make it easier to scale. Then, we'll jump into building our first renderer, super minimal, just enough to draw a square on the screen. If you're ready to keep building, hit like, subscribe, and let's dive in.
Spreading knowledge, one byte at a time.
So last episode, we set up our workspace manually, the hard way, and that was totally on purpose. Why? Because you understand how a workspace is wired together under the hood. Then, when you move to something more advanced like Beaver, it's not just magic. Now that we've got the foundation, we can let the tools do some of the heavy lifting for us. Beaver stands for Bun, Ono, Vite, and React. Basically 4 technologies working together to give us a modern, fast development setup. Bun is our all-in-one toolkit. It's like Node, NPM, and a supercharged bundler had a kid. It installs dependencies fast, runs scripts fast, and just feels snappy. Hono is a lightweight web framework for APIs and servers. Think of it like Express, but on a serious caffeine rush. Perfect for a game editor like ours and the backend tools. Vite handles our build and dev server. It's fast, smart, and works beautifully with modern front-end frameworks. And React. You already know what this is. It's how we'll build the editor UI panels and everything that the dev will interact with. Together, Beaver gives us a clean, scalable foundation. No fighting configs, no waiting forever for builds. It's flexible enough for serious projects, but lightweight enough that it still feels like fun to work with. So instead of reinventing all that, we're plugging into Beaver. It's stable, modern, and gives us all the boring stuff, build tools, routing, hot reloading, so we can focus on the fun stuff, like making the renderer, the editor, or the game engine logic. Basically, less setup and more creating. All right, so I'm back in the project, and all I've done is cleared it out completely. The Git repo is still there, but that's hidden in VS Code. Anyways, all we're going to do is one bun create BHVR at latest, and it's going to do all the hard work for us. So we're just going to put period for the name so that it puts it in this directory, and then we're going to do shadcn UI with Tailwind. And we are going to say yes to this and yes to the linter. And we're going to have no router. And we're going to use tan stack for queries, which is really nice. We're going to need that for like serving up assets and stuff like that in production. It's really nice. It allows for type safety and stuff in the future. We aren't going to initialize what we already have. We will install the dependencies. Okay, so everything is ready to go. If we clear and then we just run bun dev, it starts everything up. It has everything starting at, as the client starting at localhost :5173. So let me just give it a moment. Localhost 5173. There we are. And we've got our backend server connected up. So I'm not going to go too much into their setup because it is really irrelevant to us. I will make a copy of their app.tsx once we get moving, just so we have that for reference. We're going to just chug right along now. So first thing I'm going to do is we're going to copy this shared component or this shared package here, because we're going to create a new folder called packages, and then we're going to paste that in there. We're going to build off of this shared library here. It's going to be very similar. The only difference is in the tsconfig here is we have to go up 2 directories. We're going to be needing the DOM, and we'll get DOM dom.iterable there. That should be good. One thing in here, we do get type errors unless we come into the TS config here. And if we put outdir and set it equal to, I'm sure that it doesn't need to be this, but the when I was doing some research to try to solve that issue, that is what popped up. So now that we've looked at that, we don't need that up anymore. We can restart the TypeScript server. And then while we're in here working on this one, we're going to change its name to renderer, like so. And then we are going to add into the package.json the new packages. So we've got just these three currently. We're going to add packages asterisk. So any of the packages we add from this point on will go in there. Also in the TS config, we need to add our renderer here. So this will be at renderer, and instead of that, it will be packages slash renderer. And that's where this one will end up being. We have that. And then all we have to do is kind of add it to the client so that we can use it in the client there. So that's going to be in its package.json. And then when we come down to the other dependencies, we can do the same thing here. We can say renderer. And that will add it to the client. So we run bun I for bun install. And there it went. That means we are all set up that quick. We are ready to get working on the actual renderer implementation. It looks like we have a problem in the package.json here. Packages. Name is dot. Let's give it an actual name. GES/workspace root. Actually, we can just call it, let's just call it GES Workspace for Game Engine series. GES Workspace. There we are. And now we can move on to setting up the client, the renderer. So we'll be coming into our app here, and we'll be making some modifications to it and adding what we need to render out the canvas and the square with our awesome fancy renderer. All right, now that Beaver is all set up and our foundation is locked in, it's time to talk about the next big piece of our engine, the renderer. So what exactly does a renderer do? In simple terms, the renderer's job is to take whatever data the engine gives it, like position, color, shapes, and turn it into pixels on the screen. That's it. It doesn't decide what to draw or why to draw it. It just knows how to draw. Think of it like a stagehand at a play. The director says move this prop here, and the renderer quietly gets it done. No opinions, no storytelling, just performance. Now, what a renderer isn't is everything else. It's not the game loop, it's not the ECS, it doesn't need to know about inputs or UI, it's focused on one job, converting our scene data into visuals. The reason we're setting it up this way, so minimal and unopinionated, is because it gives us freedom later. When our structure is clean and modular, we can layer on new features like images, animations, lighting, and even a full 3D renderer without tearing the whole thing apart. Because we took our time to get our foundation right with Beaver and clear module structure, we'll be able to grow this engine fast without refactoring everything every time we add something new. So let's build this renderer simple, clean, and flexible. All it needs to do right now is draw a square. We'll let complexity come later when we actually need it. All right, let's jump into the code. All right, so we're going to try to get this going and get it done pretty quickly. One thing that I have done, I got rid of the base URL In all of the TS configs, it is no longer necessary in TypeScript config files. So that was causing me some issues. So what we'll do is we'll come into the renderer, which I did properly rename to renderer. And we'll come into the index.ts inside of source. And we're going to import a renderer type, renderer, and a type color. We're going to define those in our types folder. So from our file types, and then this is where we can define those. We can export type color is equal to a string. For now, that's fine. And then we'll export interface, and this will be renderer. So this is where we describe what a renderer is going to look like. What's the interface that our front end client is going to interact with, what makes it a valid renderer. So a renderer is going to have a read only, which just means it's going to have a getter for this value, and it's going to be width, which is a number, and then we'll do the same thing for a height. It'll be a number, and then we'll have resize, which will be a function that takes a width as a number, a height as a number, and then it's going to update the width and height for our canvas and such too, so that we can do everything correctly as far as the math and positioning and sizing and all that. We'll have a clear function that can take an optional color, which will be of type color. And so that will either clear the screen or fill it with a rectangle of that color. So then we'll actually create a function to draw rectangles. That'll be a number for X, Y is a number, for width is a number, and H for height is a number. And then this can also have a color that we pass in. This is going to be a function that returns nothing, but it draws to the screen. And getNative is a little helper function in case some other file wants to actually use the canvas paintbrush, is what I call it. And that's going to be type canvas rendering context 2D. And that is it. This describes the basic renderer. That's all it's going to have. So then now that we have this description and we are importing the description, now we're going to define it, and so that we can actually use these methods. And so first thing we're actually going to do is we're going to create a function, make canvas renderer, and that's going to take in a canvas and return a renderer. Renderer. So let's say we have our API, which will be a renderer, and we'll return that. Return API. So this is obviously not a renderer yet. It's missing a lot of things. One thing we'll do is we'll get a context. So ctx is equal to canvas.get context 2D, because this is going to be a 2D game engine to start at the very least. If ctx, then we're going to throw an error if we did not get a rendering context. 2D context not available. Simple enough. That just means it's going to error out, and we have nothing else to do if we can't draw. So we're going to set some internal variables. Underscore width, it's like a private variable which just exists inside of this function, and also we'll probably end up using width down the line, so underscore just separates them so there's no conflicts. This will be canvas dot width, and height will be equal to canvas dot height. Then from here we start to define this. We let some of this stuff start coming into place. So we have to define a function that this will return width, and then we have the same thing for height, return height, and then we have resize, width, height, and you can see because we've already defined this, it knows and tells us what we should be doing. Width, height, canvas.height is equal to height. So when we resize it, we are resetting the internal variables, and we're also setting the canvas's height to match. Then we want to create that clear method that just takes in an optional color, which I think we already set it as optional. So this, we are first going to, because we'll do one of two things. So if there is no color, We're just going to clear a rectangle. So that means ctx.clear rect 0 and width and height, like so. Else, we're actually going to say ctx.fill style is equal to the color that we passed in, and then ctx fill rect, and it's going to be the same thing as clear rect, but we'll have set that color up there. There we go. That is everything for clear. Next thing is to be able to draw a rectangle. So we'll have x is a number, y is a number, u is a number. I think actually we've already set this stuff. So we can just say x, y, width, height, and color. We've already defined them. No need. This is going to fill style. We're going to fill the style. So meaning we're going to set the color of the canvas or of what we're about to draw. ctx.fill rect x, y, w, and h. And then we need one more method to shut the linter up. So that is going to be the get native, and that's just ctx. So return ctx. And this defines the renderer, and it's going to be able to be expanded upon in the future. So let's come up into app.tsx and let's minimize this. We'll just blow it all out. We'll export, and you can see we just are wanting to export a function called app. So function app, export default. All right, we're going to use a few things. We're going to import, use effect, and use ref from React. Then in here, we're going to set const canvas ref is equal to use ref, passing in HTML canvas element, and then use effect. This will be what we do one time, and then we'll return. Let's return a div with a class name equal to width screen, height screen, flex. I don't think we need any of that for now. We just need this here. And then canvas ref is equal to canvas ref there. And that's all we need to gain access to the ref, except for it needs to go in brackets. So now everything special is going to come in here. We need to get our import make canvas renderer from renderer. And then we'll come in here. And you know what? I'm actually going to, before we do put all that in here, let's actually make this a bit easier. I'm going to copy this. We're going to create a new folder in components, and we'll call this editor. And we'll separate this out a bit so that it, what did I just do? Oh, I created a new folder. Delete. I'm not thinking. All right. New file, core/editor.tsx. There we go. Now we have a file that we can edit. I want to change the app up to be even simpler. So we're going to just import editor, and we'll just import editor like so. From @components/core/editor. And then we can actually get rid of all this. And the app is just going to have this here with the editor. That's all this is going to export. So, or that's all that it's going to do in there. So now we can change this to editor. This is editor. There we are. So we need to also, let's pull, I think that's fine there. We might want type renderer. There we go. And inside of here, we're going to say if the canvas ref.current is not set, we'll just return and don't do anything. Const canvas, we need the canvas, remember, to pass into our renderer, is equal to that canvas ref.current. And then we want the parent canvas ref. Oh, actually, it's just canvas.parent element. Then we can set up a renderer by running the make canvas renderer method, passing in that canvas we just set up. Then we can run the initial resize with the parent.client width and parent.client height. I think that's actually fine without it. So we'll create an X variable that we set to 20, and it's not going to be anything special right now, but we'll see pretty quickly that we can do something cool with it. First thing we do is clear on the renderer. We clear it out. We'll pass a color that we want the background to be, and then we draw our rectangle. We'll set its X to X, and then we'll have static numbers for the Y width and height. We also have the option, we need to pass in a color like so. And then I think that is everything there. All right. And we may need to run bun build. Run build. Let's see if it builds. That will update the package. Let's see. I think that's fine. All right. Looks like the only problem that we have, this is renderer. I think that should be good there. So bun dev, we have a problem in the fact that we don't have components core editor. Let's see, failed to import @component. I already see it. There we go. There it is. There it is in all its glory. It is rendering fine. So one thing that we can do is we could say const ID is equal to set interval. Every 16 milliseconds, we run whatever is in here. So what we can do is we can say X is equal to X plus 2. So it starts moving across the screen. As soon as its position is modulus width minus its width. So the renderer's width minus the width of the square. It's going to continue to move to the right and reset to the left. And this will run every 16 milliseconds. One thing you want to do to be proper is at the end of a use effect, you want to return and clean intervals and things like that up. So you want to clear interval. And then it is now moving. There we are. So I think we're good. That is where I wanted to be right now. Very simple. Today we leveled up our foundation. We pivoted to Beaver, Bun, Hono, Fight, React. So we're building on a fast, modern, battle-tested stack instead of reinventing the wheel. Then we wrote the smallest possible renderer, just enough to put a square on the screen, and clarified its boundaries. It turns data into pixels. That's it. No scene management, no game loop, no opinions. Clean roles, clean code. But why does this matter? By keeping responsibilities tight, we can grow fast without refactoring everything. Beaver handles the plumbing, our renderer handles the pixels, and we're free to focus on the real engine features next. What is next? We'll build a proper engine core and wire up the update loop and the render loop. We'll also drop in a basic ECS, nothing fancy, just a get it done version with entities and components and systems, and we can get them working together. From there, adding features becomes incremental and painless. So if this helps, like, subscribe, and share the repo with a friend who is learning. Got ideas and better patterns? Drop them in the comments. We're learning in public. Thanks for watching, and I'll see you in the next one. Let's build.